Okay, I would like to continue with highlighting how to draw the arrows in the energy cycle diagram for Hess's law. One thing that I would like to highlight here is that the enthalpy change for root 1 is equals to root 2. Although in root 2 you need to add up enthalpy 1 and enthalpy 3. So you can see here enthalpy 2 equals to enthalpy 1 plus enthalpy 3. The concept is just like the resultant force that you have learned in physics. Okay, for example, going up, turn to the right, then this line is the resultant force. So A, B, C, A plus B equals to C. Now, let's look at how we can construct the energy cycle diagram and how do we place the arrow. Okay, first let's look at the question. It says that calculate the enthalpy of solution. Okay, so the question that we are looking for is enthalpy of solution. Okay, so here the answer should be, it should be solution. Okay, now, so what do we need to find? We need to find enthalpy of solution. So you need to know the definition for the enthalpy of solution from solid change to aqueous ion, produce aqueous ion. Okay, so usually the one that I want to find, I will put on top first. Okay, now let's see what is given. Okay, you can see here the given one is gaseous ion change to aqueous ion. Means that it is the enthalpy of hydration. Although the question never mentioned, you must know the definition for enthalpy of hydration. Okay, so if we have enthalpy of hydration, then we know that, okay, we need to construct one that is from gas to aqueous ion. Okay, so this is the enthalpy of hydration. Now, we have another one that is given lattice energy. Okay, lattice energy is from gaseous ion to solid. Okay, given is negative. However, if let's say you want to use from solid go to aqueous, from solid go to gaseous ion, you have changed the equation. Okay, you have changed the equation, so you need to change the sign. Okay, and then now I would like to highlight the root. Okay, now for this equation means that root 1, okay, root 1 equals to root 2. Okay, where root 2 consists of enthalpy 2 and enthalpy 1. Okay, now let us look at another example which I have changed the direction of the arrow as well. Okay, still remains the same is the one that I want to find, that is enthalpy of solution. Okay, remains the same. Okay, now what did I change or what I didn't change? Okay, so from gaseous ion to aqueous, okay, hydration, I maintain it, so I don't have to reverse the sign of the negative or positive enthalpy. Okay, and then another one is given is the lattice. Lattice is from gaseous ion to solid ionic solid. Okay, so because I didn't change anything, so it is still negative sign. Okay, let's see whether this cycle, the roots is the acceptable or not. Okay, so this is root 1, and then, okay, this is not root 1 yet. Okay, the root 1 consists of, okay, we just look at that it must continuous, like going one round. Okay, go one direction. So this is root 1. Okay, then another one, this will be the root 2. Okay, so now this time root 1 contains of enthalpy 2 and enthalpy 1. Okay, and then enthalpy 3 equals to enthalpy 2 plus enthalpy 1. Both of this energy cycle method will still get the same answer for enthalpy of solution. So this one matches the definition. The change in enthalpy is the same whether the reaction takes place in one step or series of steps. And then see here, enthalpy change is independent of the route taken. Okay, now I want to highlight another one which students tends to make mistake. Okay, for route number 1, okay, for energy cycle number 1, you can see that I have route 1 and then I have route 2. Okay, if you look at this, something similar to what you have learned in physics. Okay, so 1, then this is like the resultant force, 2. Okay, however, students sometimes they forgotten about the arrow. When they draw it like just one cycle only. So actually there is only one route. So it is incorrect. If you draw like the physics 1, okay, there is no resultant force here. So enthalpy 1 not equals to enthalpy 2 plus enthalpy 3. So actually in this, it does not obey the Hess's law. So just remember, if you are going round the clock, okay, or you are doing clockwise, means it is wrong. Okay? So that's all for this part. What I will summarize again is you can use whichever method you want. Okay, for example, I can use negative lattice or I can use just lattice. Okay, and then I will still get the same answer provided that I have two roots. Okay, root 1 equals to root 2. And be careful of going round the clock or clockwise. Okay, that's all for this part.